My name is Anna Gill, and I am going to be presenting on the Wittig mechanism. So, who invented the Wittig mechanism and when was it discovered? Well, hence the name, George Wittig invented it, obviously. He was born in 1987 in Berlin, Germany, and is a Nobel Prize winning chemist for his work in studying phosphorus containing compounds. He graduated from the University of Marburg in 1923 and furthered his education to later become a part of the faculty at the University of Heidelberg, where he continued on with his research and studying. Wittig focused his studies in the involvement of carbanions and later discovered a class of organic phosphorus compounds known as yields. The discovery of these yields allowed for the production of the Wittig reaction, which further provided chemists with better information in the synthesis of complex organic compounds such as vitamins A, D, prostaglandins, and steroids. Along with Wittig's achievements of winning the Nobel Prize in 1979, he also received the Otto Hahn Prize for his research and discovery of the boron-phosphorus containing compounds as important reagents in organic synthesis. What is the Wittig reaction and how is it useful? Well, the Wittig reaction is a series of mechanisms that involve the transformation of converting carbonyls to an alkene and a triphenylphosphine oxide. However, you must be careful when choosing the carbonyl because aldehydes and ketones are capable of performing the Wittig mechanism, but esters are sometimes not compatible with the reaction. This transformation involves the production of an yield from a phosphonium salt. And you may be wondering what an yield is, because I for sure did. Well, an yield is a species of opposite formal charges on adjacent atoms. There are various different forms of yield, however, in the Wittig reaction, it's specifically, as stated before, a phosphonium salt. Furthermore, the yield produces a resonance with the positive charge on the phosphorus and the negative charge on the carbon. This yield acts as a nucleophile on the Wittig reaction, making it available to attack the other electron poor or electrophilic atoms. The location of the double bonded carbons is fixed, allowing for a major advantage in the synthesis of alkenes. In order to properly carry out the Wittig reaction, one must synthesize a phosphonium yield. The organophosphorus yield is used where the phosphorus will be holding more than 8 valence electrons. With stabilization of the yield, it becomes more acidic, therefore strong bases are needed as a reagent. During the SN2 mechanism of the formation of an yield, methyl and primary halides are used in order to produce the best Wittig reagent. The identity of the bases is also very important as it results in the mixture of the EZ isomers. In the presence of a ketone, there is predominantly more Z isomer, with still some E isomer present. If the reaction were to be done in the presence of lithium or sodium, it results in the production of only the Z isomer. On the other hand, if you were to only desire an E isomer, the use of the stabilized yield is suggested. The purpose of the synthesis of the yield is for its reaction with the ketones and aldehydes. This occurs, again, from the attack of the nucleophilic alpha carbon to the electrophilic carbonyl carbon, which in the end produces the substituted alkene. There are two intermediates formed in this reaction, the betaine and an oxophosphatane. Again, it is important to note, like I said before, that the EZ configurations are also resulted in the end product of the synthesis of the Wittig reaction. Here I've included a video of me going through the mechanism of an yield as well as the mechanism of the Wittig reaction. I have not talked throughout the entire duration of the video of me drawing. However, there are still some clips of me talking, so I will just see you in the next slide after this video is done. The triphenylphosphine undergoes an SN2 mechanism where the lone pair on the nucleophile attacks the carbon atom, which then attacks the leaving group, resulting in the formation of a carbocation. Furthering that, the carbocation becomes deprotonated, resulting in the formation of the yield, which is known as the phosphonium salt. The nucleophilic attack on the carbonyl from the lone pair on the yield results in one of the intermediates being formed, known as the betaine. Following that, there is the formation of the four-membered ring intermediate by taking the lone pair on the oxygen and attacking the phosphonium ion, resulting in the second intermediate being formed, like said before, the oxaphosphatine. Finally comes the formation of the alkene, where there is a breakage of bonds to form the resulting double bond between carbon 1 and carbon 2. All right. So, due to its reliability in the applications in the synthesis of organic compounds, chemists have used the Wittig reaction in a variety of synthetic mechanisms. As stated before, the Wittig reaction is useful in the synthesis of vitamins and opioids, which have assisted in the advancement of synthetic chemistry. With that being said, by taking a closer look into the Wittig's application in the use of opioids, more specifically nalmefene. Nalmefene is an opioid antagonist used in the management of alcohol dependence, otherwise known as a treatment for the prevention of addictions. This to me was very cool when I found out that the mechanism I were to be researching had an impact in the formation of an opioid that helped the treatment in alcoholism because that has had a serious effect in my life. And I just thought that it was cool when I found out that the mechanism, the Wittig reaction, um, it is a useful step in the production of nalmefene, which helps alcohol management and addiction. The Wittig reaction is useful in the production in nalmefene as the naltrexone reacts with the yield, methylene triphenylphosphine, which is the first step of this mechanism. Following that, the method stated by Fishman and Hahn has stated that naltrexone reacts with the yield in sodium hydride, which results in a free base. In addition to that, there are other ways that the formation of nalmefene is produced using different solvents, which then need to be purified in order to have a proper, in order to use the drug um, safely. Um, and I've included references as well. But that is the end of my presentation. Thank you for watching, or thank you for listening, and have a great day.